All right, so as I was saying, we are going to be starting off with causal loop diagrams in Vensim today. So we're starting to learn how to use this software package. So before I get into that, though, I know there's a question about the double feedback, or about the double negatives.
Reinforcing and how odd minuses makes it reinforcing versus.
Well, odd minus would make it balancing.
Sorry, even minus make it
reinforcing.
Reinforcing and odd numbers.
Right. So what was your question in particular?
Well, yeah, because it strikes me that when you're talking about what we're doing here, there's really two things going on. There is the parameters themselves that are being impacted, which are really reflections of a static system. They're a snapshot in time.
Right.
We're talking about dynamics. So
right.
When we're talking about balancing and reinforcing, what you're really talking about is the impact on the rate of change. So when you've got a negative, a single or an odd negative, we talk about one, then it is reducing the rate of change regardless, even though the rate is actually increasing the parameter values, but you are still reducing, no matter what. If you've got a single or an odd rate, you are reducing the rate of the rate of change.
Well, I would say that to be careful with the term reducing,
well,
you're introducing a negative correlation
right.
between the two. And so when you have two, as long as they're the same time scale, then they can, you basically say that for every 1 unit of this quantity, I get, for every 1 delta unit of this quantity, I get a certain delta unit of this quantity the other direction. Then if you have another one, that kind of gets, right.
And there is going to be a difference in the behaviors depending upon the specific influence of the individual
right.
Parameters that are having an impact. Because like some things can have a dramatic change in the values, some things can have a smaller change in the values. So there is some dynamics that's going between those. But in general, if you always have a single negative, you're always going to be having a net balancing effect as opposed to a reinforcing effect.
A single negative, yes.
Right.
Or an odd number. That's right. That's right. The net. And again, and the time scales are kind of an important thing that it's outside the scope of this class. But if you take a more advanced class on feedback, then, like as an example, I probably shouldn't do it, but if I turned on the microphones in the room and the speakers in the room, you would hear a reinforcing echo. And that feedback effect, often when you hear these feedback effects, it's a single tone. And what you'll find is when you study the mathematics of feedback, then what you find is that due to delays in feedbacks, what you can find is certain components of a signal will actually experience a different magnitude of link. And so you'll find that everything but because of, if you think about sound waves, they have wavelengths to them. And so you can get this effect where if you get a reflected wave, it can actually, some of them will end up canceling each other out, but the other ones end up reinforcing each other. And so in that case, over some parts of, in the case of acoustics, some parts of the frequency spectrum, you get a net negative, but for certain specific parts, you get a net positive. And that's the reason why when you turn on a speaker near a microphone, you actually get one tone that grows while all the rest sink. And that's why as a good sound engineer, you have to find that tone and add extra damping just to that tone to guarantee that you have a net negative effect. So it gets more complicated. And so there are counterexamples you can think of, like, well, this negative doesn't seem like it should always balance out. But the general perspective is, so long as the time scales are kind of similar together, and you can consider what we call the systems be lumped systems, so you don't have to worry about the delays as much, then it kind of works that way. But once we explicitly start modeling the delay, then the nominal slow thing might be that, well, 2 negatives make a positive. But when the delay there, that suggests that if you start really cranking things fast, then you might actually get to a point where you can get a positive. And that's what we'll see, like in the shower example. When you try to regulate the shower temperature, you can actually get scalding hot water as you're trying to bring the water back down. And that's because the delays are so long that the timescales don't quite line up correctly. And you get this feedback anti-compensation effect. So again, it's kind of the mathematics that are outside the scope of this class, but you actually can model that and predict what those oscillations will be and such and all that sort of thing.
So. Well, it's also true for reinforcing there. You can have things like population, for instance. If you've got a replacement rate below 2.1 for families, then you're going to still have a negative increase in population. You have decrease in population.
Mm-hmm.
So yeah, there's some funky things about the mathematics there that doesn't seem
right.
They are kind of counterintuitive.
Well, we'll see that when we go into more population examples. Like that 2.1 thing will actually show up because it'll be when we think about inflows and outflows separately. It, when what we'll end up doing is combining them. We'll see when the net flow is beneath 2.1, it's as if there's a single inflow that is decreasing, or a single outflow or whatever. So the 2.1 is of course relating to a balance point between inflow and outflow, and whether it's up or it's still an exponential. It's just an exponential growth or an exponential decay, because there's no actual feedback. And well, there is feedback. Well, anyways, we're getting kind of out, but we'll get there. Yeah. All right. So, but today I want to take what we've talked about so far in CLDs, bring it into Vensim. For those of you interested in Insight Maker, if you go under this lecture on Canvas, there's also a little tutorial I've made for building CLDs in Insight Maker. So that's another option there. So Vensim, getting Vensim. So if you go on to Canvas, I've decided to just create a module called Simulation Software Resources right here. And so that was in the course information, so I just popped it out. And underneath there, I've got links for the I think, which is if you're interested in the textbook models, totally optional. Vensim, this is a page, how to install it and where to find additional resources. In Insight Maker, where to install it and find extra resources. And so all of that's there. Today, we're focusing just on Vensim. So if you are going to download Vensim yourself, all of these links are on Canvas, but you can go to the page. You have to fill out this form, and it'll email you a download link. I highly recommend you uncheck the subscribe link when you submit that form, so they don't send you their newsletters. You can download the software, and then you can, when you install it, it'll say what type of installation it is. It'll say commercial, evaluation, academic, educational. Make sure to select academic, educational, or if you do like evaluation, after like 30 days, I think it'll kick you out. So that'll give you unlimited access to Vensim for purposes of the semester. So that's how you get Vensim. It's already installed on all of these computers. So if you open up one of these computers, and then you can either find it under applications, or you can use Spotlight, so like Command Space and then type in Vensim. You should be able to find it there. Right-clicking is actually useful in Vensim, so I'll get to this. These computers by default are configured with a mouse that has a single button. If you go into the control panel or the settings panel, you can configure the secondary button as a right-click, or you can use the control key. Whenever I refer to right-click, you'll hold down control and hit click on the sort of single button, the default single button, and that'll get into that. And I'll remind you of that when we get to it. So that's how we get Vensim. Now, there are a bunch of Vensim tutorials online. Again, see the Canvas page. One of the popular ones, interesting enough, is written by a guy named Craig Kirkwood. So that's underneath the toast here. It says Craig Kirkwood, who is an emeritus faculty in W.P. Carey here at ASU. So he's got a pretty comprehensive tutorial on how to use Vensim that they used to teach in his system dynamics modeling class over in WPC. So, but it's using an older version of Vensim, so the window doesn't quite look exactly like the window that you'll see, but all the same concepts apply. So that and other tutorials are linked from Canvas. The latest version of Vensim, version 9X, is a little different than the version that you'll see in my screenshots. They updated the interface a bit. And plus, a lot of you are using dark mode on your systems. And so there's a couple of things we want to do. So for one, if you're using dark mode on your system where you've got to have the inverted colors, then when you open Vensim, one of the first things you want to do is go to the view menu and then go down to dark mode sketch towards the bottom, and that will invert the colors. Otherwise, Vensim behaves a little funny when your system's configured in dark mode, where like it'll end up rendering black text on a black background. I don't know why it can't figure out that it's in dark mode and automatically switch like every other program, but they make you manually do it. So if you run dark mode, I recommend turning that on. The other thing I recommend you doing is by default in version 9x, the toolbar is going to be tiny and it's going to be icons without words. And that's fine if you're a Vensim expert, but if you're just getting started, it makes it really hard to find things. So the first time you open Vensim, before you get into all the details of what the heck Vensim does, you can go to the tools menu, you can go to the options, it'll pop up this options window and you can go over to toolbars, this tab here, and you can change the font of the toolbar. You can increase it to whatever you're comfortable with, and definitely turn on this show icon labels. And then your toolbar will look somewhere down here. So when I say click on the variable button, you'll be able to click on the button that actually says variable under it instead of trying to figure out by mousing over what the variable button is here. So like some things like A, the variable button actually has an A icon. You're like, why A? Well, it turns out for esoteric reasons, the A is for auxiliary. So, so I could say click on the auxiliary button, but then it references variables otherwise. So it's just easier if we've got the words there. So highly recommend tools, options, turn on show icon labels. And then I think these settings should stick even in this room as long as you're logging in with your ASU ID. All right, so before we get into any details, are there any questions about that? It all makes sense so far. Okay. All right, so basic tutorial on drawing causal loop diagrams in Vensim. This, again, my screenshots were taken from a version of Vensim just a little earlier than yours, so it looks a little different, but as long as you turn on those labels, we should be able to find everything, and I can help you find them things here. So when you open Vensim, you get a blank canvas. It looks like this. Vensim is primarily used for either drawing CLDs or simulating stock and flow diagrams, these system dynamics models. We'll get to that, but we're only focusing on CLDs today. So when we open Vensim, we're going to focus on these three main buttons plus two auxiliaries here in the toolbar. The variable button, the arrow button, and the loop annotation. So for CLDs, just remember those buttons and find them. In the later version of Vensim, this comment button is way over to the right. So it's not quite as close as these variable and arrows. So you should find variable and arrow next to each other, but comment maybe like way over there somewhere. But locate those three because those are the big three that we're going to be using. The other two that you should know where they are the delete button and the move size, which is over here next to lock sketch. So really those five are the main things that we're going to use when we draw CLDs in Vensim. So locate those so that as we go from one to the other, you'll be able to find them. And I can open up Vensim on my side too. I'm a little scared of what's going to happen with this kind of hodgepodge of things I've got connected here, but we will do what we have to do. All right, so how do we create these CLDs? So if you open up Vensim, if you go, and I'll see if I can open up Vensim and do this myself. So I can follow along with you all. All right, here we go. All right, good. That worked okay. So here's Vensim. This should look more like the one that you've got. Blank canvas here, all the words across the top. Everybody good okay for here? Anybody have trouble that needs me to come around? All right, so what we're going to do is we're going to create a variable on our CLD. So I'm just going to click on this variable button and nothing is going to happen. And I go down and pick a spot on the canvas and I will then click on that spot and type in my variable, hunger. Now it's pretty small here, so I'm going to do something a little advanced that I'll get to in just a second. I am going to right click on a blank spot here, and you may not have to do this, but I'm just doing it because I'm projecting and it's really hard for everybody to read what I just wrote there. So I'm going to right click on a spot over here, and that will pop up these default canvas settings here. And so I want to increase the font, the default font here. So it's set to Courier 12. So I'm going to go ahead and undo the default. And just for mine, I'm going to crank that font up to like, I don't know, 30 and see how that looks. All right, so that looks a little better. Everybody can read that, I hope, or at least see that something's there. Okay. I'm going to go ahead and save because it just prompted me. Do you want to save for automatic backup? And that will make things a little bit easier later. So I'm just going to save it on my desktop, but I could save it anywhere. I'll save it as example.mdl. Okay, so I created my first variable. Now, if I want a CLD, then I want to create an additional variable so I can connect those together. So I'm just going to go back to my PowerPoint so we can follow along with that. So everything is up to date here. So I'm going to create a second variable called amount eaten. So I'll hop back into Vensim and do this, but just for anticipating here, I'm going to click. I already have variable selected, so I don't need to click there again. I can click on another part of the canvas. It'll create a new variable, and I can type in amount eaten. So that's what I'm going to do. So I'll tab back over to Vensim. Click over here. Type in amount eaten. And so here, I might like the way it did it there, but notice there's a little handle. These little circles that show up are called handles. They allow you to manipulate the variable in different ways. That shows in the bottom right here. Because my font is so large, it word wrapped that. If I don't like that, I can grab that handle. I just by mousing over to it until it turns into a different shape, and then I can make the variable bigger so that it doesn't word wrap. Are everybody okay so far? Got through two variables? Good, all right. And all this, for those playing around at home or want to do this later, all this is down here. All the instructions are down here. I know it's behind the transcript, but if you need to do this at home, we're just repeating that here. So the next thing in the causal loop diagram is adding the causal links. So I want to add a link from amount eaten to hunger and hunger to amount eaten. So I'm going to click on this arrow button up here, and then I'm going to click on my source, amount eaten, and then I'm going to click on hunger to create that arrow that comes over. And then, and I'll show you this live here, what's going to happen is it's going to draw a straight line. Well, it's going to draw a line between them, and it will have a little handle, a circular handle on it. And I'll be able to grab that handle and drag it up and down to adjust the bend of that line. So let's see what that looks like. If I can find my mouse again. Oh, there's one mouse. There it is. Okay, so arrow. So I'll do hunger. Click on amount. So I clicked on hunger. I clicked on amount eaten. I drew this arrow, and I'm going to grab the handle and pull it up. And it creates a little arc there. And if I don't like the gap around amount eaten, I can change the sort of the size of the box around it. And then I can, anticipating what I'm about to do the reverse arrow as well. So I can click on amount eaten and then click on hunger, grab the handle and pull it down so that now I've got both right there like that. All right, so I got two links. They're not labeled. They're just adjusting here. Any questions about that? Everybody okay? You found the links? And they are anchored to those. So if you were to move these texts around, the links will move with it. So it's, it's a nice tool in that respect. All right, so let's see what's next. So now I said that those links weren't labeled, and I want to label them as a positive link or a negative link, and I might want to add delays. That handle allows us to do that. So that handle that shows up in the middle of the link, if you right click on it, or on a Mac, if you don't have a right click button, if you hold down Control and then click on it, then that will bring up options, link options that you can edit for that link. And those link options allow you to do things like add delays, change the color of the link, change the thickness of the link, and change the polarity. You can label it plus, minus, S, or O. Remember, S is same, it's synonymous for plus. O is opposite. It's synonymous for negative. And then you can choose where you want to put the polarity mark. You want to put it near the arrowhead. You want to put it inside or outside. So you have a lot of flexibility here. So I'll go ahead and do that. Tab back over to Vensim. Probably go through this mouse hunting task again. Oh, I think I saw it. Okay. So I'm going to go up to this one. I right-clicked on the handle, and this says options for arrow between hunger and amount eaten. Well, I know that if I eat more, my amount eaten, if I'm hungry, so the more hungry I am, the hungrier I am, the more I will eat. So that is a positive relationship. So I'm going to go down, and I am going to change the polarity to plus. If I wanted to, I could put other things in here, but plus works fine for me. If I wanted to, I could change the color of this to a green or whatever. I'm okay leaving it as blue. And then I can, play with the position or whatever. I think that looks fine on the outside there. So I'm going to leave it, but it's up to you how you would like to do that. So there's a little close that's hidden down here that I'm going to try to. How do I draw the line from hunger to amount eaten? Yeah, when you have arrow tool selected, and then you click on hunger, and then it should create one anchored to hunger, and then click on amount eaten.
How do you stop it? What I'm doing is I'm clicking on one, drawing it there, clicking on that, and then when I start moving again, it's drawing another line. It's anchored.
Oh well, if once you manage to click on one and then click on the other, it should let go until you click again. So if it hasn't let go, then it hasn't registered that you've clicked on the sync yet. So so if I were to look at yours there, so if you were to click on that.
Yeah. Can I click on this?
Yep, click on that.
And I move.
Yeah, so that just so I think
it says it didn't get hunger. So
yeah, I'm gonna hit escape there. So let's try that fire to hit amount eaten, and then find another spot here. Yeah, it's just because I think your hunger box is kind of small. So let's.
Oh, so I can increase it.
Yeah, maybe able to increase the size, maybe create a little bit more of a target, and then that should do it. Anybody else having any? Yeah.
I don't know. I want to move it, but
Click the move, and then try to grab. Like, do you want to grab amount eaten and move it, or
like the corner of the arrow.
Oh, I see. Like where it's
Yeah.
yeah. So in that case, sometimes all you can do in Vensim is just delete it and redraw it. Because yeah, sometimes that's unfortunately a good thing. Anybody else? Okay, good. All right, so we hit our polarity. Anybody trouble online? I am gonna risk bringing up the chat here. Okay. Oh, bring up the chat one more time. All good. Okay, good. Thanks for that. All right, thanks for bearing with me on all of this. So I'm gonna hit close. And I wanna do the same thing with this arrow. So I'm gonna right click on this handle, bring up my arrow options. Options for arrow between amount eaten and hunger. If I eat more, I am less hungry. So that's a negative link. And so I am going to change the polarity marking down here to negative. And for kicks, I might change the color too. So let me move this up. And I'll maybe undo the default. And maybe, those of you who can't see it, but on my screen, when I clicked on that, it brought up a color wheel on my other, my second screen. So if I go over to my second screen, I can see if I can pull that color wheel back over this way. And maybe I'll select red-ish. And so there, that's the color I want. Maybe. And so now that I've made a red a label there, but it didn't make the line red. It just made the, well, actually, maybe it did make the line red. So there, I can do that. Now, if I want to, I can also add a delay mark. So if I check that box, then when I get off the highlight, we'll see it added 2 vertical bars. So when this becomes unhighlighted, what we should see is a red line with 2 vertical bars showing there's a delay. So as I eat something, it takes a little while before my hunger is reduced within the red mark there. So now I've got all of those things there. So everybody see that, how I added the delay just by checking delay mark. And I can change the color by turning off default and then changing the color. Then you right click on the handle or control click on these computers on the handle.
This was originally
well, yeah, that's right. The Windows version looks nearly identical, and that's probably where the main development was, on the Windows side. All right, so any questions on that? Everybody good on the links? So I'm going to go ahead and hit close over here. I'm going to expand this a little bit and then hit close. And then I'll go ahead and I'm going to click move just to get out of the link tool. And now we see I've got a nice blue line up here, the red line down here, the blue one's marked plus, the red one is marked minus. So we don't have our loops labeled, but we've got our links set up and they're looking pretty good. All right, so let's see what we've got next. Okay, so we need to add that loop annotation here. So that is the 3rd button in our toolbar, the comment button. And basically, we're just going to click on comment. Try to use the pointer here. So we're going to click on comment, which again, on your computers, it may be way over in the right side of the toolbar. And then after you click on that, you can click anywhere in the middle of this to create that comment. And then it should pop up a dialog box like the one that I'm going to go up to here. It's going to look a little bit different because this is a newer interface, but all the same stuff is there. So let's see what it looks like in this version. I'm going to go into Vensim. Oh, I thought I saw a mouse for a second. Oh, there, down the bottom. There we go. There we go. Okay, so I'm going to click comment, which way over here. I go to the middle here. Might put it a little bit up here just to make room for it. And it's a little less cluttered than the old versions, but all the same stuff is here. So in this comment here, I can say, well, I want this to, if I go down to built-in clip art, it's got a bunch of different things that I can put in the middle here. Now, this has got one negative loop, or sorry, one negative link. That's an odd number of links. So this is a negative feedback loop. So I'm going to choose the negative clip art for that feedback loop. So I could do other things. I could do graph decay. That's another one that's popular here. I could do the scales. That's another one you can use for balancing, but I'm going to use negative. So I'll go up and hit that. Now that by itself doesn't show the little, like if I were to hit OK here, let me get rid of the word comment. If I were to hit close here, then all we see here is it's just a giant minus sign. And so that's not quite what I want here. And I accidentally created a new comment. So this is good. I'm going to hit delete on my old comment. I'm going to click move so that I can make my minus sign a little smaller and move it over a little bit. And then I'm going to right click on it. That's what I just did there to bring up the comment editor again. And so what I want to do here is add the counterclockwise loop, or in this case, I want a clockwise loop around it. So I want it to be a minus with a little clockwise loop around it. If I look under appearance here, it's got none, box, clear box, etc. By default, it selects clear box. I'm going to go down here and say loop clockwise. And then I can change things like the font color and stuff like that. So if I wanted to, I could change my font color here. This is, I think, more for the notation, to a different color. Rather than me worrying about this color wheel, I'm just going to leave it as its default. But and then the outline color. Well, for now, again, so we don't, I think you can see in principle, you can stylize up the way this looks using these options here. But for now, just a negative with that counterclockwise is fine. If I want to add text, I could put something here like, this would be like hunger reduction. And if I were doing that there and hit close, we can see how that looks. Now that put hunger reduction on top of the minus sign. That's not really that easy to read. So it seems like that's the way I should have done that. But in reality, if you want to look more like Moorcroft's, then what I probably want to do, highlight that, is change the text position to be above. And let's see what that looks like. And it's, I may need to move these guys around because the font is so big. But hopefully now we've got something that looks a little bit more like what we've seen in Moorcroft, where we've got this little hunger reduction. It's clear that I've got a negative feedback loop and it's labeled. So I've got us labeled. So the hunger reduction, totally optional. I don't need to put that in there, but if I do put that in there, I want to make sure I select above so it's not written on top of there. The thing that we always want is some indication of the loop feedback, and then that the counterclockwise or clockwise arrow matching what's going around it to make it easier that so I can see that this annotation is for this loop. So now we've got a full CLD that is annotated, if the loops are annotated and the links are annotated, and you can do further styling of color and so on. Any questions on that? Has everybody got something close to that? The negative sign, so that is, if I go to the, so I'm gonna, right now I'm in the move tool, I'm gonna click on that to highlight it, right click, and that is part of the built-in clip art is this, I picked a negative sign out of here. Oh, okay, that, is it possible you're in dark mode? It looks to me, because you're the chrome around the outside is black. I think it's because your system is in dark mode. So that's why, like, there's a black for me and white for you. Okay, any other questions about this? Does everybody feel? Well, that's again because I think because your system is, because you're like, my system's got the gray around the outside and yours has got the black around here, and that's why. Again, because Vensim's not sensitive in the right way to the way the system's dark mode setting, then if your system is in dark mode, it will change fonts to match the dark mode, but it doesn't necessarily change the right parts of the canvas, which is why under view, you have to do that explicit dark mode setting. So I think if you change your system back to light mode, then this black would turn black into, like, I think this is following my system settings, where my system settings are light mode, is what I'm saying. All right, any other questions? Everybody feel good about that? Okay, any questions online? Good, all right. So I think we've managed to jump pretty much ahead here. This is me just saying the same stuff. In the older versions, it was down under graphics image, but we can see it's under clip art now in this version, but exactly the same options. So in this example, I chose to make a food intake control instead of, I called this one over hunger regulation or something. And so now we've got our causal loop diagram. And what we'd like to do is export them. So like put in a report or homework assignment or whatever. And so all you can, to do that, you can click on move size, and I'll show you this here in a second. And you can just highlight a rectangle around the CLD that you want to export, and then go up and say copy. And when you paste it into your Microsoft Word or PowerPoint or Google Docs or whatever, it will paste in a vector format so that if you were to make it big or small, it won't be pixelated. A lot of students are tempted to just take a screenshot, and you can do that, and that'll work most of the time. But the downside of doing the screenshot is you're going to capture the white for one thing, and as if you make this larger or smaller on presentations, then it may not be very crisp. So that's why it's better to use the Move Select tool and copy as opposed to just taking a screenshot. So I can show you that. Just go into Vensim here, get on my comment editor. Then I will go ahead and maybe I'll make this a little bit bigger. And I'll go up to Move here. And then I'll just go and click on a corner, drag around. And then from here, I can either use and go to edit and copy, or you can just click on the copy button right here. And then if I were to open up, Microsoft Word, for example, and go in here and just go up to edit and paste, then I get a halfway decent, who knows what the alt text will be for that? Oh, it's a Venn diagram according to Microsoft Word. That's their artificial intelligence right there. This is a halfway decent reproduction of that CLD. It's pretty crisp. I can zoom in and out, whatever. So that would be the way to grab these CLDs and put them into your reports. All right, so any questions about that? These are all things that on the homework assignment, I'm gonna have you draw some CLDs. And so you'll practice all of that. And even though I'm gonna ask you to upload the MDL files from Vensim, the main thing that Jorge is gonna grade is going to be in the Word document. And so that's why you've got to make sure that after you draw your CLDs, you've got the ability to export them cleanly to your Word document with putting a little caption underneath each, and that's all explained in the assignment. So that pretty clear? Any questions about how to get a CLD into here? And we could have, made this a little bit cleaner. We could have cleaned up, this clip art. We could have made, these fonts a little bit bigger. The arrow sizes we could have made bigger. But this passes. This does what we need it to do. But the very tiny arrows for one thing, and the kind of the thin lines, I think they probably, for this application, maybe I could have made those a little bit thicker and made it clearer to see. All right, so let's see if I'm forgetting anything. All right, so so the other cool things that we can work with here is, I've already did this once, but if you right click on the blank canvas, or again on a Mac with one button, control click, then that will bring up the default settings where you can go through, and again, I already did this with the fonts, you can change the default line type, the default line color, the default fonts, all of that sort of stuff, so that you can do it once, and then it'll change it on everything you haven't manually changed and every new thing you draw as well. So that's one nice thing that you can do. And the other thing is down here at the bottom, it looks a little different on your version. There are these quick change options where you can highlight things and then go down to here and very quickly change things on multiple things that you've highlighted. So if you, let's say for example, you had a bunch of lines that were negative links and you wanted to change them all to red. Well, you can control click and highlight all the lines that you want to change to red. And then once they're all selected, then you can go down here and change the line color in one place, and it'll change it on all those lines simultaneously. So if you find yourself repetitively doing one thing over and over in Vensim, most likely you can highlight or select by doing like holding down Control or Option or Command, and then clicking on multiple things. And once multiple things are selected, you can edit them all batch-wise using these things down here. And I've got a video demonstration of how to do that on Canvas if you like more info about that. All right, so any questions? All right, due to these sort of technical issues, this went a little bit slower than I liked, but let's knock out the rest of this here. Okay, so there's a homework assignment, a new one that should be relatively quick. You just draw 2 CLDs, one CLD for question 1, another CLD for question 2. And so in the question 2, you have to build your own CLD. In question 1, you're just going to annotate a CLD that I gave you that is lacking annotations. So let's try to think how to build our own CLDs. So, or how to just generally edit other people's CLDs. So this is a causal loop diagram kind of mimic that I borrowed from the National Research Council that's trying to communicate something about climate change. And so if we look at this up top here, it's got temperatures rise, goes to Arctic sea ice melts, goes to as reflective ice disappears, darker ocean water absorbs more heat, goes to temperatures rise. Now they're trying to communicate a vicious positive feedback cycle, but they don't formally meet our conventions for what a CLD should look like. So what are some problems with this CLD? Yeah. Absolutely. So rise, melts, and then whatever the heck this thing is. The idea here is that we want to have all noun phrases. So your variables should be noun-like, noun phrases. So instead of temperatures rise, what could they have put there? Temperature, right. So let's go and I'll just try my best to make these edits. I guess I can, for kicks, try this. So temperature. And then likewise down here for Arctic sea ice melts, what should that maybe be? Sea ice, yeah. So, or Arctic sea ice. I guess I could just get rid of the melts, make it easier on me. And then this one's a little bit more complicated, but we probably have got some fancy words that we could put there. Any idea on what we might put over here? So this has to do with the reflectivity of the ice versus the ocean. Does anybody know a fancy word that starts with A that has to do with the reflectivity of, yeah. Albedo, right. So albedo is a noun phrase, right? It's it is something that is measurable. That's, I guess, what I'd say here. So we can refer to the albedo of water or ice. And so I can put albedo here. Pardon my scratch. Hopefully that's clear. That's awful. Does everybody get that? That's albedo. Okay, so now we just need to annotate the links here. So we know that as temperature gets higher, what happens to sea ice? It gets lower, right? So should this link up here be positive or negative? I hear a bunch of negatives. How many people say negative? Good, yeah, that's what I would do too. I'd say this is negative or opposite. Either one works for me. So I'll put a little negative / opposite. All right, and then down here, Arctic sea ice, albedo. So if I increase the amount of sea ice that's available, what happens to the albedo? Does it go up or go down? We'll say, albedo is, just as a reminder, albedo is proportional to reflectivity. So if you increase the albedo, you increase the reflectivity. So ice is white, it's very reflective. So if I increase the amount of ice, do I increase reflectivity or decrease reflectivity? How many people say increase? Like nobody, yeah. So that's what I would say, increase as well. So this link down here, I'm gonna say is a plus or a same. So I'm going to put, for this link, I'll put it in kind of the inside here, plus or same. And then this last one here, albedo, temperature. So if you increase the albedo of the Earth, what happens to temperature? Does it go down or go up? If you increase reflectivity, over time, does temperature go down or up? Down, right. So increase here, opposite thing there. So and I could even say, maybe I'll put a delay here for kicks. And then up here, I'll say this is a negative or opposite. So I've now labeled all my links, negative, negative, positive. I see 2 negative links, which means overall, this is a positive feedback loop. So that, or I could also call this a reinforcing feedback loop or a vicious cycle. So does that make sense? That's CLD. 3 noun phrases, 3 links. Yeah, and because I use Zoom to do this, then this won't be, well, it'll be in the video. Okay. All right, so let me see if I can clear these. Aha, okay. All right, so, all right, another relatively simple one, and this is one that'll be very similar to what you're going to be doing on the homework. So I'm describing this system where you've got a bucket of water, and that bucket of water has a water level, and we're looking at the water level, we're staring at the water level, and we would like it to have there's some target like level. So let's say it's like up here, that's our target water level. And so I'll call this target. And we would like the water to come up to that target. And so as we're watching it fill, we look at that gap and we turn on the water to bring the water closer to the target. And then once we're at the target, then we turn off the water to keep it at that target line there. So if I look at this description of this process, I can pick out some key noun phrases that I might label on this thing. And so, for example, I could say, well, look, I've got flow of water and water level. Well, those water level is changing over time, and flow of water is what's causing it to change over time. So those are good candidates for me to what I might put up here. So I'm going to put the flow up here, and I'll put the water level down here. And so now I just need to figure out what the link polarities are here. Now, if I increase the flow of water, what happens to the water level? Does it go up or down? Up, right. So if I add more water, the water level will go toward up. It'll get more of it. So I'm going to put a plus here. And I'll just use plus, but just know I could have also done same, S. Now, if the water level gets, now imagine, I'm just imagining it being under the target. So if the water level rises toward the target, so it goes up, what will happen to the flow of water? It'll go down. So assuming that we've got a rational person controlling this thing, as the water level comes close to the target, they're going to start tapering off the water. So I will say that this is a negative up here. So I look at that and I got a positive and negative, a single negative. So what sort of feedback is this? Negative feedback loop or a balancing feedback loop or a counteracting feedback loop. Don't put all 3, only pick one, but any one of those would work fine there. Any questions about that? Questions online? Sorry that I'm not as attentive to the online. Again, this is sort of a different setup that I was ready for here.
Well, assumption that you're dealing with continuous systems. You're not dealing with on-off situation.
Yeah, so there are ways to extend these ideas with something called describing functions to nonlinear systems that switch. So this is system dynamics modeling is modeling average behavior. So if you have a switching behavior, you can think of it as like, what is the average duty cycle of the switch? And that would be kind of, so this is simulating a continuous control policy. So we're not flipping the water on and off, but you could say, instead of putting flow of water up here, I could have done a duty cycle of flow or something like that. And then so you could say, well, 0% of the time would mean it's always off, and 100% of the time always on, and 50% would mean I'm flipping back and forth. So there are ways to extend this to those discontinuous control cases, but we're just modeling the average behavior. All right, so in general, whenever I ask you, so this is what sort of assigned the question 2 is on this assignment, I'm going to have you to draw your own balancing feedback loop. And I'm going to say, choose 3 variables and 2 links. I think that's what I say. You have to have 3, or maybe no, I say I choose 2 variables and 3 links. It's one of those, like, but here's this Noxa, this is showing it with 3 links and 3 variables. And so you can come up with a whole bunch of systems that fit this archetype here, where you have a goal. So that's my target water level. So target water level. I've got an action. That's my flow of water. And I've got a level, and that's my water level. And then that forms this balancing loop. And so you can think of a bunch of different, like this could be, I want to give a bunch of examples because I want to give the options for you to answer this, but this is what I'm looking for in the second problem of assignment B2, in part so to practice this, but also just so you can practice having something to draw that's not something I've already given you as in Vensim. So that's what we're going on with that one. All right, so any questions about this general idea? Notice this goal that I've added in here. You don't have to have that in there, but usually these balancing feedback loops have a goal, and that goal is affecting the flow, the action, to bring the level up to the goal. So very often the flow is proportional to the gap between the current level and the target. And we've seen examples like that, like the thermostat example is an example we already saw that fit this example, like 1/2 of that thermostat example. All right, so questions, everybody good? All right, I'll clear that. Okay, so now the thermostat example is actually, this is the extension of it. So what if the bucket had a leak? Well, the controlling the flow of water, that's like controlling the temperature in a house. And the leak is like, well, it's like leaking heat out of the house to the cold outside. And so that is a second balancing loop. So you've got a rate coming in and a rate going out. And those 2 feedback loops intermix, creating that what we called the last time escalation behavior. And that will end up causing the control to always have flow coming in, and there always to be leak coming out or evaporation or whatever. So this is how we can build up from these things and get more interesting dynamics. So that's just linking to what we've already done here. So this is exactly the thermostat example from the last time. But I'm not asking you to draw anything that complex. All right, so I might skip through some of these things just because I want to make sure we get to the first part of that assignment. But this is another sort of exercise, and we can sort of say what's what is not productive about this CLD and what's left out and so on and so forth. Can anybody have any comments on, so this is a CLD that's supposed to represent the relationship between population, birth, deaths, and food supply. And so, so what are some things that maybe we've said we don't want in a CLD, or what are some improvements that can be made? Yeah. Well, sure. So the links need to be labeled, the loops need to be labeled for sure. Yeah, births in 2 places, that's kind of weird, right? Otherwise that the same comment. Yeah, so that's one thing. We probably don't want this extra births up here. I'm going to leave it in just so we can have the opportunity to label that link. Or I mean, I guess maybe I can take it out here, and instead I could say, well, maybe those should have been here. Like I've got a link going up from population to births and a link coming down from population to births. So I already have births on the inside, so I could have just had those links here. And then I wouldn't need this whole complex up here. And then it makes the feedback loops a little bit more clear. Now, the other things is we'll learn, the professionals who do this really hate when CLDs have boxes around variables. They really want variables to just be, in a CLD, it's just words and links, and that's it. So that's the other thing that is unconventional here. In a normal CLD, you wouldn't normally put boxes around variables and call it chart junk. They really get testy about it. Then the labeling of this stuff. So see if we can quickly label this. So population, as you get an increase in population, what happens to your food supply? Decreases, right? More people, less food. But if you I'm sorry, that was, I think I have the ability to erase. All right. Yeah, so that's an opposite relationship. As you increase population, decrease the food. And, but if you increased food supply, what would happen to deaths? It would decrease. So the more food's available, the less death. So that is a decrease. Now notice there that I try to reset my narrative when I go around here. I don't want to like set up a sequence of events. Like I'll say, when I increase population, what happens to food supply? Well, it goes down. Then I forget that I did that. And I say, okay, now reset. If I increase food supply, what happens to death? If you get momentum going, then you'll often like refer back to whatever you did here when you need to be focusing on just this link. So if I increase food supply, deaths should go down because you have more food available, less people starving. If I increase the number of deaths, well, by definition, I reduce my population. So that's a minus. If I increase food supply, well, I might get more births. Now, this might be kind of poorly modeled because it's not like food supply is creating births. I mean, it might be. There might be some effect like when people are fat and happy, they're more willing to make babies. But this, I don't think is what I think they're trying to communicate here is that there's a limiting effect of food on births. And to me, that probably causally happens through the deaths channel already. So I'm a little suspicious of this link, but I think that probably what they mean there is a plus, where they're trying to communicate the theory that if you have more food, you'll have more births. Now, I drew that extra line in earlier, but it looks like I didn't need it because it was already there. So now from births to population, more births, more population, more population, more births, because more people will have it. So now now that we've annotated all this, we can look for all of the loops, and I see this here is a growth loop. It's going to be hard to draw, but so let's see if I can do, well, this is a positive feedback loop. I'll try to do the positive first. So that's our growth loop. And then if I look around the periphery, I see 3 negatives. Well, that around the periphery, that 3 negatives looks to me to be a negative feedback loop. But I also see it, so that's via death, there's a negative feedback loop. So if I were to go around periphery, population, food supply, deaths, that's one negative feedback loop. But because they've got this suspicious food supply line here too, whether we like it or not, there's an additional negative feedback loop from population to food supply to births. So if we buy this, that there is a link between food supply and births, then there are these 2 negative feedback pressures that are being balanced by the 1 positive feedback. And overall, we'd expect probably some sort of S-shaped growth curve here, where once you get enough population, these 2 pressures will hold things to some carrying capacity. But if you don't have that much population, the births will drive things. So any questions on that ugly little CLD? Okay. So we could add other things there too. So let's clear that. All right, so again, due to the slow start, we're not going to get a chance to work on this that much ahead of time, but I'll try to give you some hints here. So just looking ahead to the weekend, Muddiest Point due on Sunday. The next lecture, we've got another reading, so there's a perusal and so on. And there's this assignment here that is due not this Sunday, but the next Sunday. So the assignment that is being distributed today, you've got not just this weekend, but next weekend due as well. So that's what is hidden behind this toast here, is the assignment response is due Sunday, not this Sunday, the next Sunday. So what is that assignment? So I've already mentioned the second part of the assignment is you're going to draw a negative feedback loop in Vensim. The first part of the assignment is you're going to annotate a complex CLD that I'll give you that is lacking annotations. And the background behind this is the old classic VHS versus Betamax competitive exclusion ecological technology problem. And so once upon a time, there were VCRs. Once upon a time, there were two VCR formats. You could argue about which one was better technologically, but they both coexisted for some period of time, and then VHS ended up winning this sort of battle. And so this is a little bit like Android versus iPhone, where it's two competing formats that do very much the same sort of thing. And so with that, I kind of borrowed this example from Andy Ford. There's this nice kind of kidney-shaped couple of CLDs, where what I want you to do is label all of these links and then label the loops. And the hint here is that there are two loops. There's this kidney over here is a feedback loop. This kidney over here is a feedback loop. The other hint that I'm going to give you is that both loops have the same polarity, even though they'll have a different number of negative feedback links. So what I'm saying is the evenness or parity, as we say, between the negative feedback links is the same, even though we'll have a different number of negative feedback links on one side than we will on the other. So we'll have, and it kind of should make sense because VCR or the VHS and the Betamax it's sort of symmetric. So we should get like the same feedback pressures here as we have here. So we're gonna have two types of the same feedback loop competing with each other. And that will lead to this kind of competitive exclusion setup here. So if you're to follow this around, things like, if you have more VHS tapes in stores, then you have to ask, like, what does the VHS market share do? Now, it's hidden behind this. Let's see if I can get rid of this a little bit, or maybe I'm afraid to hit escape here. Maybe I can get away with that. Yeah, right. So VHS market share is just the number of VHS VCRs divided by the number of total VCRs. So with that, you can say, well, if there's more VHS tapes in stores, well, I can give you this one that we would expect that if there's more of the VHS tapes in stores, then there's going to end up being an increase. If you increase the number of VHS tapes in stores, one would imagine you're going to increase the number of VCRs that play VHS tapes. And so this would be a plus. And then similarly, on the other side, if you increase the number of Betamax, you are going to decrease the number of VHS VCRs. So this would be a minus. So that's kind of a tip that I've given you, is that you're going to have a plus coming in this way and a minus coming in this way. And yet, this feedback loop will be the same polarity as this feedback loop. So in Vensim, I'm going to want you to draw this guy, annotate all the links, and annotate the loops. That'll be part one of the assignment. And part two of the assignment is to draw that balancing feedback loop. So I think that's all I've got for you today. So any questions about that? We are at time and I don't want to keep you over. All right, so again, sorry for the tech problems. I'm going to figure out where the HDMI cable got moved off to. Attendance exercise, you guys have been so patient. I'm just gonna get everybody the attendance, even if you're not here. So don't worry about that. If you have any questions, feel free to come up after while I'm fumbling around looking for the HDMI. And otherwise, have a good weekend. Any questions online? If not, I hope you guys also have a good weekend. All right, I'm going to see if I can figure out how to close this then.